Hi guys, welcome to another codefilm. It's been 2 weeks since we released any film with regards to what we do here, that's technical software um, services or content. And what we want to look at now is software or application containers. And this is a concept, not just a concept, but a technology that is actually being used most of the time now, especially in modern deployment um, considerations. And the reasons why it's being considered is what we want to look at in this cold film, and also some practical aspect that has to go with this. So the catch or the buzzword is Dockerization, and it's mostly software or application containers. The term Dockerization is because of the technology you are going to use to be able to achieve the purpose of having your softwares or your application in containers. So if you are going to go with a technology or like a technology product like Docker, then it's going to say you are Dockerizing your application. But in a general sense, it's containerization or put your application in a container. So we are looking at software application containers, and then the product that we want to use to look into what this entails is Docker. And in the process of doing that is the Dockerization. So let's just get straight into it. So you ask yourself, if you are someone that has done traditional deployment before, or if you've experienced traditional deployment before, which will have an experience here on this code film, you realize that most of the time when you develop your application, your solution, you developed it on your own host environment or on your own personal device. You don't really know the environment you are going to deploy your solution on per se. So for instance, if you developed it in somewhere in sub-Saharan Africa, and now it turns out that you have to deploy your solution in a on a server that is sitting somewhere in Korea, as to what the how that environment or how that server has been set up, whether there are some environment variables, argument properties, you think about it as whatever configurations has been done on that environment for it to be able to accept your solution. Most of the time you are not privy to it. So you just know maybe it just runs this Java, or even if it runs Java, you are not sure what version, or they could also tell you like it's not it's something that um, can bring about a lot of problems. So for instance, you deploy that solution to that Korean server, and then you realize that it worked fine on your device, but when you threw it over the fence and you sent it to that server, it turns out that it didn't deploy or it didn't run as expected. And that's all because of how the deployment was done. So when you go with the Dockerization approach, or when you go with containerization approach, let me say containerization approach, but with a technology like Docker, it promises you a lot of um, benefits. And those benefits is what has compelled all form of application deployment or application um, release onto servers to now follow this standard of containerizing your application, or making sure you put your applications in containers. So it's a modern approach of deploying softwares, and it's very, very good. It's aside it being good, it's reliable, it's very reliable, it's very efficient, and then it doesn't cost so much. And then when I say it doesn't cost, like there's no much effort required. Let me say there's no much effort required to go around this. So these are some of the benefits it promises you. So it promises you that you have applications in a container. It promises you operating system virtualization. It promises you that your application will be highly portable, which we'll look at gradually as we develop the use case for our code film. It promises you that your deployment will be very friendly. It promises you that you have your application or your solution properly encapsulated, which means that don't really bother about the environment that you are going to put your solution on. When you go with a containerization approach, whereby you are intentionally picking that application, let's say an instance of that application, and you are putting it into a container, whatever that contains that application for it to work properly or for it to run as expectedly is going to be pro- properly encapsulated. It's going to be properly encapsulated. And it also promises you that you're going to have a self-contained isolated unit. So in natural sense, in natural words, the container you're going to put your application just with normal shipping containers. If it falls into the ocean right now, and provided there is waterproof or not, it's not really going to be affected by the environment it's going to be deployed into. So your solution is residing in a self-contained isolated unit. So anything that has to do with the host environment or the destination server that you are going to put your solution on is going to be isolated from it. So if you've done some configurations, environment variables, arguments, some properties, and you've actually infected the destinations servers and the destination servers setup or how it works. The approach with going with the container approach is not going to let your application, it's not going to affect your application because your applications will be in containers. So that's the explanation of the self-contained isolated unit. And then it promises you independent system binaries or environment, and it's not going to be influenced by whose environment variables, arguments, or properties. And that's all regards the self-contained isolated unit. So it's based on the concept of operating system virtualization, whereby you're actually having a, s- a snapshot of an operating system, and that snapshot operating system is what your application is actually residing on. So you have a process. So instead of having a bigger operating system and then you um, having multiple applications inside that operating system, each application is actually going to sit in its own operating system. So that's the operating system virtualization. So just like virtual machines, whereby with a virtual machine you have you have actually siphoned or you've leveraged on resources from the host environment to create smaller machines. So you depend on the hard disk, you depend on the RAM, you depend on the CPU to actually create smaller virtual machines or smaller computers. So instead of if you have a 1 terabyte hard drive, you can actually take some 2 or 5 or 10 gigabyte to create a small virtual machine. And on that virtual machine, you have to actually install an operating system on it. So the same way, in that same vein, they are saying that no, why do we have to go with virtual machines and you depend on the host environment to actually have some resources dedicated to it. So the idea is rather, let us rather have a technology that can actually give us, can actually capture snapshot of the operating system. And with that snapshot of the operating system, you put our applications. So our applications actually sit in the operating system, but not on the virtual machine. There's a difference. When it's on the virtual machine, it means that just like this computer, multiple applications can run on this computer. So whatever environment variables I set on this computer is actually going to affect or can affect other applications that will run. So if one solution that I have developed, for instance, is a payment solution, and mostly it's going to be, let's say, local payment. I wrote it with maybe a Java version, Java 17, and it works perfectly because there were some API features I saw in Java 17 that I said this is going to be super. So let's write this remittance or this local payment API or international payment API with this Java version. That's perfect. Then later on, but it turns out that there's a legacy application that helps out to do interbank transfers or moving money from one bank to another bank. That software has been there since since the digitization or technology started. So we are talking like way back like 2000, and it has been running on a Java version that has kept it stable up to now. Probably they've done upgrades or updates gradually, and it's not something that they've done a full-fledged migration because of the consequences or the effects that can occur when that happens. So they don't want to risk that kind of upgrade. And here it is whereby we are on a host machine, and then because of rerunning all applications on one host machine, the developer comes, he makes a mistake, and then he installs his own Java version and does a setup on the environment, and he tries to run it, and then it turns out that the whole environment um, gets infected. Then we are in big trouble. We are in big trouble because it's going to be a big issue. So instead of relying on just one operating system to run several applications, why don't you rather do this? Why don't you rather have a way each so that each application actually runs in its own operating system? When I say runs in its own operating system, each application has its own operating system um, encapsulation of fabric that is working inside. So if we go with the Docker approach or the Dockerization approach, the operating system that has been set as the base is what all applications are going to take their samples or their snapshots from. It's not going to come from anywhere else because that's how we've decided to do it. So that's with the difference between the Dockerization and the virtual machine approach. The virtual machine approach is still the same host device, but it just takes some resources and install different operating system. And in that case, one virtual machine, for example, this Ghana server can run n number of applications on the same server, on the same environment, with the same properties, and each application will be coming with its own infections, which could be at a risk. Just imagine every developer coming with his own infection on the server. Hey, that's a risk. If you don't want that, why don't you rather go with another approach whereby it's the same one server, but on that server, each application that is coming is not coming to reside on the same host environment to cause an infection, but rather each application is coming in its own encapsulated operating system. So like a pill, just like the matrix, the red pill or the blue pill. So you're coming with a pill, and your application is sleeping inside the pill, and that pill is the operating system, and that encapsulation has been made possible so that your application runs in its container or runs in its unit. So instead of running in a larger environment, we create a smaller group for it, and then we virtualize it and we use it for just your application. So your application can go ahead and infect that operating system base that we've set for it. And that's the beauty of the Dockerization. So it seems I've talked too much in regards to this, and so that's the promises of all this that comes from containers, operating system virtualization, and what's not. So right now we want to go ahead and look at traditional deployment. And when we look at traditional employment, we look at the modern way of now going about this solution that has been brought, that's going to make our lives very, 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 very stress free and easy. And it's going to make our lives very comfortable, and also it's going to make your deployment very friendly, and then all the effort that goes into maybe deployment is going to be cut short. Yeah. So first of all, let's look at traditional deployment. So we have this our solution. So let's believe that this is a remittance service that we've built. Then traditionally we have to build this project and take the application and deploy it on the server. That's the traditional approach. So let's just go ahead and look at this. So terminal. So first things first is we'll clean the project. When we clean the project, then we'll build it. So we are going to get the executable that's going to make it possible for us to run the application. When I say the executable, the format or the packaging that makes it possible for us to run the application. So it's going to be application.jar. So this is a jar file that we need. So we'll go ahead and locate this jar file. When we do that, we'll clean. Okay. Let me just moving clean then. Let me do moving compile first. Then I'll add the moving package. Moving package. Alright, so we'll go ahead and take this application and we are going to put it on a virtual machine that has one that has an operating system that's been set for it that all applications will have to come and infect or reside on. So we'll go ahead and locate the file. Alright, so let's go to this location. Okay, so that was the formal one. So this is our file that we need, the executable jar. So we're going to copy this file. So this is the executable jar we have. So this is just this is our remittance application or application that we built. So we have to actually let this run. So traditional deployment is get this and put it on the server. Once you put it on the server, go ahead and start the application. That's the traditional approach. So we're going to deploy it on rather app server. We're going to do this deployment on the app server. So we actually can do this in several ways. One is to use file transfer protocol FTP to do that. That's because we just want to move the file from here to this server, from this environment to this server. Then once we do that, we start application. So we'll go ahead and start the app server and I'll use FileZilla to do this. If not, you could go ahead and use other approaches that are out there. We've actually looked at deployment in virtual machines, so it's not something I want to look from the very beginning. So we just want to understand. Just want to understand this. Okay, it says powering up. We just want to understand how the deployment is being done. And there's a link to that codefilm showing right now. So go ahead. Let's start our app server. Then we'll move our solution to our app server. Then we'll run it. So this is just taking a solution and infecting it on the host environment or deploying it on the destination environment. And then later on, look at a case whereby we are coming with also another solution and we want to put it on the host environment. That's our destination server. And it turns out that our destination server is not going to allow us to run that because, as we've explained earlier, that we didn't just go ahead setting up the environment. That's a destination environment. It was following some principles. So it's been set up or configured to run with some certain parameters or some arguments and some constraints. And then we are now going to put an application that meets that constraint there. Another application will come and doesn't meet that constraint. So are we now going to so how do we handle this? Because the solution is working. It's a payment solution. Everything has been written or prepared as the problem statement says it. And then we have a live server that is always running. And then we are just bringing our solution to the live server. So are we going to now downgrade or upgrade our live server just to meet that particular solution in real time? Like if you think about all these business cases, you can see the disaster that is ahead of us. So it's too much of a risk, too much of a risk. So instead of going that approach, we say no, let's go with another approach whereby everybody should put the applications in containers. So in the container, go ahead and do whatever you want as you would have done it in an operating system. Bring it to us and let's just run the container. The container is not going to affect it's not going to be affected by our host. That's the destination server's environment. It will run in its own unit or its own container, self-contained isolated unit. So whatever that it wants to do, it can go ahead and do that. So we don't have a case whereby I'm coming with my solution with this version and these APIs or these configurations and environments, and then we bring it on the server. Then it turns out that it's a live server, it's running, but Jake just joined the team and then he has put his solution. He has written the solution like a rocket science engineer and he's so excited about it, but it cannot be deployed because of the business case or the risk that is associated with that and the damage or the disaster that can occur. Right. So let's go ahead and move to our app server, and then let's go ahead with one that is friendly on the environment. So go ahead and enter the app server. All right, so we are actually in the app server. Then what I'll do now is just to get the IP address of this destination server and move the file to this server. So it says 192.168.133.94. So 133.94. So let's go ahead. 133.94. 192.168.94. Then app user. Then app. Then the secure way and connect. So okay. So what we do is that let's move this file to, let's just put it in our app user. Let's just put a file here. Let's have a file here. So first things first is let's actually find where this file we want to do our work is. So it's at let's move this to the desktop. Let's drop it in the desktop. Then we'll pick it from the desktop and go ahead and put it on this environment. Alright, so this is it. So we'll drop it just here. I have an apps folder, but I think my apps folder has okay, this is the WAR file of it. So this is the jar. So you can put it in an apps or app user. I just don't want to have a conflict because we've done the cool films from deployment before on this. So just since it's not the same, let's just drop it here. And let's just wait, see the status afterwards. Right, so it's done. It says successful transfer. So let's go to our server and let's check and see. Right, so so we'll go to CD apps. So we have our application there. That's application, the version and then the jar file. So we'll just go ahead and start the program. Let's see how it will behave on this environment. Also, this is fantastic. So it turns out that the environment we are trying actually having our solution on is not really disturbed by how our solution was brought or how our solution was prepared. In other words, um, it's not bothered about. It hasn't thrown an exception or it hasn't screamed in our faces that hey, there's an issue with your solution you're bringing and the environment we have here. It hasn't said anything of such a sort. So you can go ahead and actually test our API now. So let's test our API from our local environment, our local host. So we'll call 8082 and then application hyphen WS. That's the contest part. So we'll go ahead and just do that. So okay, so let me start sorry, let me start with kill. So we'll do a kill HTTP and you know the IP address 192.168 dot 133 and 94 133 and 94 and it's on port 8082 application.us. That's the first thing. We just want to do a curl first. So let's just curl it and see. So actually what we are doing is that we are trying to call an endpoint in this API or in this application, in this solution, because we built a solution to run on a number of, we built the solution to run on, to run, to build the solution to solve a problem, and it's running on a number of use cases. So we are trying to test our use case. So we can actually go to the API and just see which endpoint we can actually call. This is just a test to just let us know that the application says it's running, or we can call our service in this environment without issue. So we'll call API and we'll call greetings endpoint, just a test endpoint. And we'll go ahead and call API and greetings. Alright, so let's go ahead and fire. So we are calling from our local host environment here. Rename. So this is our local host to that remote server or that destination server. So we hit it. So fantastic. It's able to give us a response. And the secret behind is that we will be there's because we've done some deployment on that server, the port to that application has been open. If the port was not open, we wouldn't have been able to call the API. So what we are grateful to is that yes, we are able to see that it's running our API, which is fantastic. So it makes sense that hey, we deployed our solution on this environment and then it was working as perfectly as expected. So we don't have a problem. Now, this is the problem. Jake has come, this traditional deployment. So we've seen the traditional deployment of moving the file from the local host environment or our personal device or our personal environment or our local environment to a remote server that has been made available to us. And we've been able to see that everything is working perfectly. We didn't have an issue. So the problem now comes to that on this same environment, it turns out that another developer comes and then we have another solution which has to run on this server. It's just an app server, but think about it in the case of a live server, or even with just an app server, just think about it. The disturbances that can occur if you do not follow or do not bring your solution in such a way that it doesn't cause this environment we have here to scream and to go ahead and throw exceptions and behave in all kinds of ways that we are not ready as engineers to go ahead and troubleshoot and look at to all what's going on. That's where the effort comes inside with regards to the deployment. We want to kill that. We want to make it very friendly. So let's first go ahead and let's bring a service that will cause such a thing for us to screen. This is just one application that is working perfectly here. And we can say we have a number of applications that are here. So let's bring another application and let's try it and see. So go ahead and bring this application, which is it's an Oracle application. So let's go ahead and bring an Oracle application. Let's just pick any. We'll pick one of these Oracle applications. So this is also another solution. It's the same executable jar file. And let's say that this is a solution that is a solution from Oracle or a solution that another developer has developed. He wants to send it to the same environment. Now let's just watch out what happens. So let's go ahead, follow the same principle. Let's actually copy it to the desktop and let's see how to behave. So we also have our solution on the desktop. And then let's move it first with file transfer protocol FTP. It's on our desktop. Let's refresh this. Let's refresh it here. Yeah, so it's over here. And let's move it over here to the apps. Let's check our queue files. So it's moving our file from our local host to the server. Then we'll go ahead and use the same Java command and start the application. So we are gradually getting to the beauty of containerization. and is a modern approach of deployment that even applications that you've been using normally are now even being containerized. Something like my MySQL database. So many softwares are being containerized, and then there's a working principle behind it, which is based on Linux namespace and C groups. And we are not going to look into that here, but it's based on that concept that is we are able to achieve such operating system virtualization. So it's deeper than this, and or this is not the focus of this endpoint. We are more of practical solutions. Solutions. So we want to see problems being solved, and the engineering to it comes in when we have to look into that. So our solution is here now. Our solution is here. So Jake is done with the solution. Now let's go to the server. Now let's go ahead. Jake says he has brought his global solution that solves all the world's financial inclusion problems. Then we said, okay, fine, Jake, we hear you. Let's go ahead and just run your application and let's see what it does. So we go ahead and say Java jar and say FMW, and this is 14. Let's run it and see. Okay, so we start our application. Then we have a problem. So it says that the OpenJDK JVM is not supported on this platform. So this is an issue. In other words, Jake has brought a solution, but because of the environment we've set up, or because of the setup that has been done on this environment, it's not allowing Jake's solution to run, which is a big problem. So Jake cannot run his solution on this environment. So just think about it. It is a live server. Jake, your solution is not running on this server. Are we going to create a new server for you just for your solution so that you deploy your solution only on that server for everybody to have access to the application? How do we solve this? Like, this is just the beginning of headache, of a big headache. So this is just the beginning. So if we go ahead and actually check our Java version for this, you realize that the version we are using here is OpenJDK. But it turns out that this application we are bringing is not OpenJDK supported. So that means that there's a different JVM that it works perfectly on. So we have to find that JVM that it supports. That's the Java API, the Java JDK, the Java JDK that it works comfortably with, and actually set it up so that it can have that runtime environment to do its work. As it turns out now, what we've said here, we can't touch Jake. So we are sorry. You have a beautiful solution that solves a lot of problems, but it cannot be deployed. And that's a big issue, a big no. If you also go ahead and uninstall the version of Java or the environment that we set up here, which means that every existing application that runs on this server is not going to work. So trying to uninstall it too is not going to work. It's not what an approach we want to go with. So Jake says, fine, I get it. So there has to be a solution. And the solution that the world or engineers that are thinking ahead of us have brought out is what we are calling the Docker approach. That's just one technology that or a product that helps you to do that. There are several products out there, but the Docker product says that when you go with Docker, I promise you that your applications will be in containers, to be highly portable, deployment friendly, to be properly encapsulated, self-contained isolated unit, independent of system binaries or environment, and is not going to be influenced by the host environment variables argument on properties. So this is just the the use case bit of it. So I'll split this into two. So we'll go and look into another code film whereby we actually go into the Dockerization. That's as to the practicality of you Dockerizing the application and we seeing it also run as it's expected to run. So we've seen the conflict, we've seen what is happening, and then we definitely get what is happening at the moment. It's still the same jar file. If you look at it, nothing has changed in the extensions. It's still the same that it's still Java, it's still run as Java jar, and it's still the same jar file. If you check it, the same application.jar is still a jar file. But it turns out that the constitutes of it or the objects that are found inside or what it consists of is a problem. So, which makes you understand that you can have a solution within an application, a solution in an application that works with some levels of APIs and objects, but unfortunately, when you brought it to our environment, your solution has been rejected. So we have to prevent this, and we can only do this when we go with the Dockerization approach. So that will be it for this code film, and then I'll say stay tuned for the next bit of it, which is actually the Dockerization. And let's just enjoy what brilliant engineers have done for us. That's the Docker engineers have done for us to make our life very, very easy. So that'll be it for this code film, and I'll say that stay tuned for more and please don't go away. Thank you.